Today, we're going to learn a little bit about how to process the TIFF file that we created so we can make a HEC-RAS model out of it. So right here, I've saved the work that I did. I showed you in the previous video. I first defined a shapefile for the boundary of the area, and then I created TIFF file from the sandag layer. Of course, first step to make sure what you have for the TIFF makes sense, so you can basically drag and drop this main file, which has the largest size, and see if it's showing you anything meaningful, and the answer is yes. So if you identify this button, you can see some numbers. So this makes sense to be the elevation 14, middle of the channel, it's 10, it's deeper. Other sides 14 again. You have a pond here, so it's deeper 7, and it's getting smaller and larger in different areas. 6. So that makes sense. So you're basically done. You don't need ArcGIS. Close it. And basically, we want to import this to HECRAS, the TIFF file. So first open it, of course, create your project. You have a new project. If you want to save it on your desktop or anywhere, that's up to you. I just call this, just create a new folder here and call it tests, TT, whatever. And then under this folder, I call it test import. Basically, we're importing TIFF to HECRAS. So that's the file. So asking you the same question, are you sure about the directory? Are you sure you want to use US customer units? The answer is yes. The sandag layer has a feet unit. If you're provided with the TIFF or LiDAR or raster data that are in meters, you need to change this. After you go to the model, we can change this part. But that's not the case for ours. So basically, now we have different tools. We have the geometry tool. That's the easiest one if you want to draw it yourself. But if you want to automate things, the RAZMapper is what you need. So open the RAZMapper. And here you can basically do different things. You can save and do things. But basically, we're creating new RAS terrain. We want to create a RAS terrain. So we basically read the data from it. This is a very important step. It is recommended that you define the project special reference system. So if you don't do this, things that are imported in HECRAS, they are not georeferenced. They show you something meaningful, but they might be distorted, scaled down, scaled up. They're not going to be what you need. So make sure you classify and identify your PRJ file for the projection right now. So I say yes. So click yes to jump to the dialog where Esri projection file PRJ is set. So I do that, and projection file is this guy. I want to identify it. So this is a little bit confusing here. The PRJ here that you see is the extension that HECRAS use for project. But we don't need this. You need the PRJ file for the projection, the one that has the all the geographic information, a state plane, everything that has the units in it. So that's actually the one that I saved when I created the boundary. So I wanted to cut a portion of the raster. So that's PRJ. This is the one for the shapefile I used. I'm going to okay, and let's show you the stuff that you can see. So you need to be able to see this stuff. State plane, California 6. That's your projection showing you the boundaries, left and right, up and down, standard, and everything you need for that. So if you don't see something like this, then your model is messed up. Be very careful about it. So you okay it, and then now you can import the actual TIFF file. So this plus button, you don't have it in this test, you have it on the GIS folder and then TIFF, and that's the one that you can see. So open it and create. So do some processing, boom, you now have it. So it's showing up in your HECRAS, your channel. So that's basically a major milestone. After that, you're basically setting up things which are gonna be much quicker than doing it manually by hand for station elevation and stuff. So now that you have this, you of course want to save and also save your main window. Then start drawing things. You need to have a river line and you need to have some notation for the bank station, the boundary of the bank station, and overbanking, things like that. So basically, when you go to geometries and you add a new geometry here, call it whatever you want, geometry 1, 2, 3. And then it gives you a list of items so you can create. So your river line, most important thing. Select and then edit. So now you can make this river line. So click on one side and double click on the other side. So that's your river one, reach one, just leave it as is. And you need some junctions if you have a confluence, of course, but we don't have it here. But bank lines, that's the one that we need. So bank lines, that's basically the boundary of your main channel and the overbank. So I have it like this on this side and another one like this on the other side. It's all visual, so much faster than doing it manually like we did for those hypothetical cross sections. And some flow lines. Flow lines are basically the furthest boundary for the flow to move. So that's kind of the boundary of your between the bank station and the overbank. So on one side you might have it kind of like a larger area. This is like a parking space, so that could be something like this, and on the other side it's something like this. So basically in these main part, you have your main channel. On the other sides, you have the overbank flows. So you have these, that's good. And most important thing you can get out of this is your cross section. So we're doing all these to have some cross sections. And the goal is that to get that cross section data automatically from this terrain file, rather than just typing station elevation 1, 2, 3 all the way to 100, 200 for a complex earth like this. So cross section, then select, edit, and then you start left to right if you're looking downstream. So that's like cross section, one of them, and it automatically assigns a number to it for the station from the downstream, because as you can see, as I move forward, this number decreases. So you want as many as that makes sense. Make sure that the lines that you draw are perpendicular to your river line. That's the whole purpose. So I'm going to add one more here, and last one when I'm entering the pond. Like this. So you're all set. Save your geometry again. Stop editing. Yes, you want to save it? The answer is yes. Now you have a geometry. So now that you have that, then you can do things with it. You can do stuff like you want to see what's happening for each cross section. You can just select it. And once you select it, if you have this editing, right click, and then you can update information. So basically you want to get elevation data from the terrain. That's the whole purpose. Elevation profile from terrain, this guy. So you select this and you're getting all the information that you need to make sure it's working properly. Click this guy, plot terrain profile, and then once you click something, it should show you something that makes sense for you in terms of the elevation information. So let me do that. I stop. So then I'm done. I select this guy. I need to change the, yes. So you select, and then now you can see the stuff that you need. If you wanted to do this manually, you had like 1, 2, 3, 4, maybe 25 just for this cross section. So basically, stuff that you see, it's showing you cross section, it's showing your bank stations and your overbanks. So next one, easily, I'm done creating like 6 cross sections, as you can see, with all these features, every point that you can see. So check them one by one to make sure it's making sense for the cross section. You have a main river and overbanks. And lastly, we're in the pond, so it could be a different shape. Yes. So the pond is a little bit different. So basically now you're done with having station elevation information for your cross sections. So you stop it and you save and you close. So now you can do other stuff. Of course, you want to import this geometry to your geometry window. You don't have any right now. It's showing you just a train, but you need to open the geometry that you created in the RAZMapper. So open geometry. It's already suggesting it to you, save in the same folder. Okay, and it shows you everything you need, all the stations. So if I want to compare this with the manual method, just see how many station elevation I have here. Like for only this guy, I have 52. All these points, if you wanted to do this manually, then imagine how much time should go to creating something like this. For this one, I have 50. To make sure everything makes sense, if you want to move things a little bit, like this guy, for my bank station, it makes sense this red button to be somewhere towards left. So you always have the option for editing this visually by this guy, graphical cross section editor. In this graphical, maybe I decide to move my red point somewhere here, right? It makes more sense for this point to be the boundary of main channel and overbank. And same for this guy. I'm just showing as an example. You can do the rest if you desire so. And then, of course, you exit. Any last edit you want to do in this menu, you can see now this red point shifted. So you want to maybe do this for the other ones. But at this point, you're basically done with your cross section. So you automatically imported data from your TIFF file to your HECRAS cross-section editor. All you need to do is adding some flow data. Maybe you want to run it for your 100-year, and your 100-year CFS number is, let's say, 85 CFS. And you save it, flow. And save flow data, close. And of course, you need to go to run button, so you create a plan for this. File, new plan, and that's my plan T. The plan T has a short name of PL, and it's using geometry, its existing condition, and flow. All right. So we're going to run this. Let's review things to make sure we're not missing anything. We have geometry and flow. For geometry, we do have the station elevation numbers. What else we might need? Manning's roughness. So we don't have that yet. For steady flow, if we're running this subcritical, then we do need to know the boundary condition for downstream. And that's there. So I have a number. You can definitely obtain this through stream stats or do rational method to come up with the number that you want to run. You can have multiple entries, all up to 32,000 of them. So we're just using one number, 100 CFS, whatever, just to make this happen, apply data. And the boundary condition, I'm using, you need to pick what type. If you have a known water surface elevation, that actually could be the case for this location, because we might have tidal effects in the pond coming from the San Diego River downstream part. So that's one way of running it. If you want to do a known water surface elevation, then go to your geometry, or you can search online what is the source of data. In this location, NOAA has all the projections for tides. So I'm just cutting across section here. I press Control button, and then it changes my mouse cursor to a ruler, as you can see. And when I release the Control button, it gives me the information. So when I cut a profile from train, it shows you the pond. So I've accessed the NOAA website for this area before, and at like high tide condition, you might get something around like 8.5 foot for the known water surface. So let's run this that way. Don't do a normal depth. You're doing known water surface elevation. Is asking you what is the value of that, and I'm putting 8.5 feet. And again, this number must come from a reliable source. NOAA has that in our area. So the known water surface is the boundary condition. We have that. Then the other part that we need is the roughness. So cross-section wise, we don't have it, right? We never introduced that in the RAZMapper. You could do, you could like draw a polygon for different areas. You have concrete, asphalt, shrub, whatever, and assign that number to automate that process also. But here, we want to just type it. There is no need to do a varied cross-section like that. That difficult. With 3 numbers is okay. So I need to just change it, just get rid of this check mark, because we don't have horizontal variation too much. We only use 3 numbers. So then that column goes away. So then now I'm able to type. So here I have, let's say, asphalt on the parking side, and the main channel I have point, let's say 0.2, and this supply data. Then you want to go to the next one. Whatever resource you use, you need to make sure you have it in the window. Let's continue. No need this column anymore. So options, no horizontal variation in values. So you delete this, and then you easily type the 3 numbers that you want to use for left overbank, main channel, and right overbank. Apply. We have, now we're moving towards downstream. Options, horizontal, and then do this again. You might want to use different numbers if you're going to a different land use. If not, just continue with the data that you had. And the last one, now everything is inside the pond. So maybe that's a different type of vegetation. And for this one, we want to use something like this. These are just some hypothetical numbers to run. Let's make sure now we have everything we need. Going to this cross section. So we have numbers for the length, roughness, everything. So everything is completed. So it's a good time to save your work. And now you can run it. So it's running without errors. That's a good thing. and it's done. So of course you want to get those views for cross sections. Now you can see how much water you have in the pond from upstream. So this 100 CFS is not causing flooding in the system. You can check for all the cross sections, and you can get a profile view and everything that we discussed. So this is your profile view. You can see how channel slopes changes. It's starting from elevation around 12 and going all the way to 7. So basically this is it for basically getting results and running a model for natural system. You can use your fancy options in RAZMapper now that you have it. The results window is also available. So you can show your water depth. So now this is showing your water depth because it's rendering the terrain in it. So that's why you see a disconnection. And in reality, actually, that's a culvert. So next video, I want to show you how you model a culvert like this. I skipped this in this video to keep it simple. But in this area, next video, I'm going to add a culvert and a pipe goes underneath the road. So we want to model that. And then all sort of things that you can get. Basically, I can show your depth. You can show velocity numbers, how velocity changes across this, and things like that that are useful options in RAZMapper. Like you can animate this, like showing how water particle moves. This is called particle tracing. So this is showing you how things can change, and we will continue with the next video on how to add a culvert and make it a complete model for this case. I hope you enjoyed it.